How do you make 1 crore while you are
extracurricular tests, seminars, conferences, competitions, campaigns, programs, and all of these are on a national platform, and they help to bring awareness on pertinent global and social issues among schools. So we believe that schools, the students are the main change makers. They are the future that we want to strengthen. And hence, Science 101 is one such initiative. For this purposes, we have liaised with CSIR-NISpR. And Mr. Singh is here. Sir, can I request you to kindly...
Sure. Thank you, Ms. Chan. First of all, I would like to welcome Dr. Ashish Agarwal on behalf of CSIR-NISpR Jigyasa and express my gratitude on request of both the USO and CSIR-NISpR. He has been so kind enough to accept the invitation and to be present before the students and the teacher to deliberate what experiences he is having. Dr. Agarwal may be knowing this, that we are just a Commonwealth neighbor. And jointly we had been, the CSIR-NISpR has been carrying out a joint many activities pertaining to data center, which is there in the NISpR. Earlier it was NIScPR. So basically about this Science 101 activity, or what we call is at a science series, a webinar lecture series. The basic idea is just how to promote the students to be more adhered or to be more have a more attraction towards the science stream. We had been organizing a number of the science webinar series, and wherein we have pulled up the different experts from our CSIR laboratories, different CSIR laboratories, and you yourself has become a success story. So the scientists who are become a success stories himself in their own respective domain, students will definitely be feeling that how they can also become a scientist like the experts who has been called in this Science 101 series. So basically, this series or the webinar series is under the CSIR-NISpR Jigyasa, which the students must be well aware of, that as has been introduced in our previous lectures also, that the Jigyasa program is a CSIR platform which was formed or which was conceptualized in 2017 with the Kendriya Vidyalaya Sangathan, and it has been extended to the state government schools also, to the other government schools and the Navodaya Vidyalaya as well. So that was an extension to bring in the inquisitiveness among the students, how to satisfy their inquisitiveness towards the science. So the basic purpose is to bring out all these queries and to get it answered by the scientists. So in the case of the Jigyasa, what NISpR or the other CSI laboratories has been doing is that basically this particular platform, under this platform, we make a laboratory visit by the different students or the schools. Then there is a popular science lectures as the one which is taking place. There is a summer vacation programs. The students in their summer vacations can come, the teachers can come to the lab and then have the programs, the different programs which can be organized during the summer vacations. Sometimes the students or the teachers can become a scientist, or the scientist can become a teacher, then organizing teachers workshop, then a student residential program, then visit of the scientist to their school, just to communicate that the science is such a beautiful stream, and the student should have more particularly, they should have an attraction towards getting a science stream as well. So that is the basic idea, and that is also the one of the the approach that to reach out to the students so that the students will also feel that how it is so lucrative to be a scientist. So all these things, with all these things, I would just call the students and the teachers to please continue joining to this science series in more numbers so that more students are benefited, because the scientists like Dr. Agarwal, that in the previous lectures like Dr. Palila, they have a very less time to move out and to disseminate their scientific information to the students. So more and more students and teachers, I would request them to join and to get a benefit of the scientific ideas or the science, what the scientists are doing. Thank you.
Yeah. Thank you, sir. Thank you very much. Great introduction on Science 101 that we have all got. So Science 101 is a series of 12 webinars which will be held until March of 2023. And today's webinar is 5th in the series. And it's on a very interesting topic of International System of Units and Indian Standard Time. Fascinating because, of course, when it's day here, it's night there. How do you sort of identify when is the time, what time should it be, and what is the way that we maintain it and make sure that it stays the way it is? Of course, there's a lot of other science behind it, and I'm sure that Dr. Agarwal will touch on it. So just to sort of go over how it will be, Dr. Agarwal will first share with us his presentation, which might include some videos. And again, for the benefit of all the teachers, if you could kindly ask your questions at the end of the presentation, please. So I'd like to once again take the opportunity to welcome Dr. Ashish Agarwal. And, you know, there's so much that I can say about him. He is very, very accomplished, but I will take a moment to just highlight some of his several achievements. Dr. Agarwal is working as head of time and frequency metrology at CSIR-National Physical Laboratory and is a leader for National Timescale Project. Dr. Agarwal is responsible for National Atomic Time Scale. That's fascinating as it is, and is leading a team of 7 scientists and 3 technical officers to implement a 100 crore project on national time scale. Dr. Agarwal is currently a senior principal scientist and professor of Academy of Scientific and Innovative Research. He has his MSc Physics degree from Indian Institute of Technology, Kanpur, and a PhD degree from Jawaharlal Nehru University in Delhi. He's done his postdoctoral research work at AIST in Japan and Northwestern University in the States, Illinois States. He has, his work has led to a major reduction in the uncertainty of primary time scale, and his contributions have been recognized by our Honorable Prime Minister, Shri Narendra Modi ji, who dedicated the National Atomic Time Scale generating Indian Standard Time to the nation on 4th of January 2021. And he also declared CSIR-NPL as the timekeeper of India. So warm welcome to you, Dr. Agarwal. Very, very fascinating subject, and I cannot wait. I hope I get to ask the first question after your presentation is done. But, you know, really looking forward. So welcome once again. I'll hand it over to you, sir.
Good afternoon, everyone. I am really thankful to NISPR and United Science Schools Organization, especially Dr. Suman Ray and Neena Jain, for inviting me and giving me an opportunity to give my presentation. I'll be talking about Indian Standard Time, and I hope you can see my slides now. And yes. I'll talk about one nation, one time, which is Indian Standard Time. Why we are doing it for efficient and safe digital India. That's the national mission. We need to digitize the whole country now. We are the timekeeper of the nation, and we want to keep Indian Standard Time with nanosecond accuracy. Our motto is punctual and efficient India, which is nice to Indian Standard Time. So I will like to talk about CSIR-NPL, National Physical Laboratory. I will talk about the international system of units. I will talk about various clock technologies which are required for keeping the timekeeping in the world and in India. We'll begin with the introduction to quartz, which we are very familiar with, which we all use. Probably they are on our wristwatches. We will examine the progress in timekeeping. I will talk about something which is very special to National Physical Laboratory and which we are very proud. We have developed a lot of atomic clocks, and these are the future clocks also. We do generate the Indian Standard Time and utilize them for the nation. How the International Time Scale, which is called UTC, is getting contributed from the Indian Standard Time, that will also be highlighted. I will talk about the service which all of us use, which is called Internet Time Service, provided by CSIR-NPL. And finally, I will talk about why timing is so important, why the clocks and why the time scale and why the Indian Standard Time. What is its importance? What is its significance? Why we talk about it so much? So NPL, as such, we know was one of the earlier CSIR labs, and it was foundation was laid by the first Prime Minister. It was just before the independence on 4 January 1947 when he laid this foundation stone in NPL. We have a very glorious past in which Sardar Patel actually inaugurated the building when it was completed, and it was done on January 21, 1950. So the National Physical Laboratory is having a very special mandate by the Parliament because we are mandated to develop the national standards of measurements. And we are mandated to realize the SI units, the units based on international system. And this is the Act, the Gazette of India, where we are mandated to do this work by the Act of Parliament. We all learned this in our school. We National Physical Laboratory is always talked about in all the science books in the schools. In class 8th, when we learn about motion and time, we do talk about time interval. We talk about 1 second. And in schools, we are taught that there are clocks which measure time intervals as small as 1 millionth or even 1 billionth of a second. And we have learned that this is called microsecond or nanosecond, and how these clocks are so accurate. And when we go to move to class 11th, in the second chapter, units and measurement, we talk about all the SI units. So I will deliberate on the all the SI units, which we all know, but just want to recall them one by one. We know that there are 7 SI units: the kilogram, the meter, the second, the mole, the ampere, the Kelvin, the candela, and based on that, all the other units are based on the derived units. These are whether it is volume, area, velocity, acceleration, or whether it is force or pressure or luminance or luminous flux. You name any quantity, it is having some relevance to the SI unit. So how these SI units are measured, what are their definitions, what is the significance of those definitions, that's what we are going to talk about. They are all based on the invariants of nature, because when we define something, it should not change over a period of time. So what are those invariants of nature? The fundamental constants of nature. They are basically the based on fundamental properties of atoms, and the nature fixes their value. We are no one to fix their value. The nature has fixed their value. The first fundamental constant which is used by the SI units is the ground state hyperfine splitting of the cesium-133 atom. So we know the periodic table. There is a first group in which there is a hydrogen and rubidium and cesium. So we are talking about 1 electron in the outermost orbit. I think the cesium-133 atom is what we should look into the periodic table. So we'll talk about that, a constant which is based on the cesium-133 atom. The second constant which we use is the speed of light, which is very well known. It's a fundamental constant of nature. The third constant which we use is called Planck constant. The fourth is the elementary charge. Fifth is the Boltzmann constant. Sixth is the Avogadro constant. And seventh is the luminous efficacy of the monochromatogram radiation frequency 540 terahertz. So these are the constants of nature which are invariant. And the values have been fixed by the international organization. And the SI system says that ground state hyperfine splitting of the cesium atom should be exactly 9192631770 hertz. So that is the precision and accuracy they work on. Similarly, the speed of light has been defined 299792458 meter per second. The Planck constant has been exactly defined. The elementary charge has been exactly defined. The Boltzmann constant, the Avogadro constant, and the luminous efficacy has been also defined. So how are the units dependent on these 7 fundamental constants and invariants of nature? We know the values have been internationally defined, and they are the basis of all the measurements in the world. The 7 SI units basically are second, meter, kilogram, ampere, Kelvin, mole, candela. And they basically, the quantity is time, length, mass, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So one by one, I will elaborate what is the international system of units and how are they defined. So suppose you have a fundamental constant. So the fundamental constant, like speed of light, will have 2 parts. One is the numerical part, the numerical value, and the other is the unit associated with that. Like in the case of, let me bring the laser pointer. So in the case of speed of light, the numerical value is curly C, and that is 299792458. And the unit is square C, which is meter per second. So the fundamental constant is having 2 parts, the curly Q and the square Q. So it is multiplication of these 2. So if we change one of them, the other will also change. So we may choose 2 factors in different ways. Normally we choose the numerical value to be exactly this one, then this process will define meter per second. So what it means is that nature is already defined Q. We have no one to define the Q, nature has defined it. Now, if we want to define a unit, we need to associate a number to that. So I will elaborate it by choosing the numerical value of a fundamental constant, we may define its unit. So the whole idea of defining any unit, whether it is second, whether it is kilogram, whether it is meter, we need to define a numerical value to fundamental constant, and that will define the unit. So we choose the numerical value to maintain the continuity with the previous value of the unit. That is another requirement of the standard. Let us come to the first unit, which is based on the atomic transition. So we know all are aware of the atoms, which have nucleus and electrons. So if the electron is parallel to the nucleus and if it is anti-parallel to the nucleus, these are 2 energy levels of the atom. And these energy levels are separated by 9192631770 hertz. So we know that E is equal to h nu. So because this there is a fixed energy difference between these 2 energy levels of the cesium atom, which is at rest at 0 degree Kelvin temperature, the fundamental constant of nature is the ground state hyperfine splitting, and which has been defined by assigning a numerical value to this hyperfine splitting, to this energy difference between 2 energy levels. So the effect of this equation is to define 1 second. So what is second? We all read it in class 11th. Second is the duration of 9192631770 periods of radiation, corresponding to transition between 2 hyperfine levels of this ground state of cesium-133 atom. I will make it a little more clear in the subsequent slides that what is the meaning of hyperfine transition. Second unit which we all talk about is the speed of light, which is already fixed, and speed of light is defined as 299792458 meter per second. Now second is already defined. The number is already, numerical value is also defined. So what is undefined here in this equation is the meter. So the effect of this equation is defined 1 meter because value of C is fixed by the nature. So this is fixed by nature. This we have defined. Second, we have already defined earlier. So now what is remaining is the meter. So by this equation, we are able to define 1 meter. So meter is the length of the path traveled by light in vacuum during a time interval of 1/299,792,458 of a second. The third important thing which we want to do is that why meter is so important. Suppose you fabricate a nut in India and a bolt in USA, and they need to be compatible to each other. So because the threads need to match with each other, that is why this measurement across the world need to be same. We used to use the same meter bar to measure the bolt in USA and nut in India. Then only they will be compatible to each other. So that is why all the international trade happens because of this kind of uniformity in measurement across the world. Any measurement done in India is having the respectability in across the world, in USA or in Germany or in Japan. Anywhere you go, whatever measurement is done in NPL India, that measurement stands across the world. So similarly, third definition which we take upon is the kilogram, which is now new definition based on the Planck constant. And the Planck constant is defined by this number. And in this equation, if you can see, we have this numerical value which has been fixed by this definition. Meter has been already defined. Second has been already defined. What is not defined in this equation is the kilogram. So if we have already defined meter and second and this numerical value, then by this equation, we are able to define the 1 kilogram because the value of H is fixed by the nature. Fourth unit which we'll take upon is the elementary charge. The elementary charge is having this numerical value, and second is already defined by the SI. I already defined it in terms of cesium transition. So what is not defined in this equation is the ampere. So the effect of this equation is to define 1 ampere. And the ampere is the electric current corresponding to the flow of these many elementary charges per second. The next thing which we define is the Boltzmann constant, which is another fundamental constant of nature, the invariant of nature. And in this equation, other than the numerical value, we also define meter already, kilogram already, and second already. So what is undefined is the Kelvin. So the Kelvin is undefined, and the value of Boltzmann constant is fixed by the nature. So that is why this equation defines what? Defines 1 Kelvin. So the Kelvin is equal to the change of thermal temperature that results in the change of thermal energy, kT by this much joule. The next is the mole. The mole is the amount of substance, and we all have read in chemistry also that this can be atom, molecule, ion, electron, or any particle or any group of particles. So the magnitude of this mole is fixed by Avogadro constant, and in this Avogadro constant is already known to us, and that is the numerical value has been defined like this to define 1 mole. Last unit is the candela, and candela defines the luminous intensity. So in luminous intensity, again, meter kilogram is second is already defined, and that is why this equation defines the candela. So I'll not elaborate, but we'll have these new SI units, which are the top one is second, meter, kilogram, ampere, Kelvin, mole, candela. So now this is new SI because revised units ensure no unit is defined in terms of the one of these units later in the list. So meter depends on second, kilogram depends on meter and second both. The second does not depend on anything else other than the fundamental constant. So this is how the SI system has been defined. And we are all aware that earlier there was an international prototype of kilogram which is located in NPL India. But now this new definition has changed since 2018 when it is changed to the Planck constant. So these are the 4 fundamental constants which have been redefined in 2018 by the international organization which is called DIPM. And this international organization changed the mass of international prototype of kilogram to the Planck constant, the magnetic constant to the elementary charge, the temperature of triple point of water to the Boltzmann constant, and the molar mass of carbon-12 to the Avogadro constant. So these are the 4 changes which happened in 2018. And this is the old SI and this is the new SI. So this is all now in your textbooks of class 11th. The CSIR-NPL has communicated to NCERT, and NCERT has already incorporated this. If you open the second chapter of the physics in the class 11th, you will see all these 7 definitions which I have already elaborated to you. So length, mass, time, electric current, thermodynamic temperature, amount of sustenance, and universal intensity has been already defined in this way by the International Organization. So we are talking about the clocks now. The clocks basically needs an oscillator, and Earth is one of the oscillators. The earlier we used to use the sand clock, the hourglass clock. There was something called candle clock, in which the melting of wax was giving an alarm by this nail striking this magnetic base. So there was a pendulum clock, which we all know very well. Of course, in the mechanical clocks, we have these springs and balances. And now we use these quartz clock watches, which I will talk about, which talk about the oscillations in quartz crystals. And the modern are the atomic clocks. So they all depend on sun, water, candles, sand. So there are many technologies which have been incorporated at different moments of time to make a clock. So first one which we use very commonly is a quartz clock, the quartz crystal, which is basically silicon dioxide. The silicon dioxide, we all are students of chemistry. We know that it is having 2 oxygen atoms and 1 silicon atom, and they have a specific structure, and that is why it is called a crystal. So this crystalline structure is used to create an oscillation inside the crystals. And suppose we represent silicon atom by plus and oxygen atom by minus. So then we can define this crystal structure of silicon dioxide, the quartz crystal. So there'll be two molecules will have 6 atoms, and if we push this crystal from one side, we compress it, we'll have net positive charge on the top and net negative charge on the bottom. You can see more positive charges on the top and less positive charges at the bottom. So similarly, by pulling it, we'll have opposite charges, the more negative charges on the top and more positive charges at the bottom. So this is called piezoelectric effect. So when there is a crystal is at rest, there are balances of the current, charges cancel each other, and the current will flow, zero current will flow. But as soon as we have a force which is applied on the crystal, the meter will deflect, and there'll be more negative charges on the top and more positive charges at the bottom. And this is why it is called a piezoelectric effect. The opposite thing will happen when we have a force in the opposite direction. There'll be more positive charges on the top and more negative charges at the bottom, and the direction of the current will reverse. This is called piezoelectric effect, and we all are aware of the piezoelectric materials. The piezo phenomena is the one where we create the oscillations in the crystals, and this is what is used in the quartz crystal also. So by applying the battery to this crystal, we can create oscillations in the crystal, and these crystals will elongate or become fatter. And this is kind of oscillation which was used by these scientists in 1927 to make a quartz clock. So these are quartz crystals which are basically oscillating, and they have a fixed frequency, and the frequency is also defined here by the way the crystal is cut. So the piezoelectric effect happens in the quartz crystals, but now there are issues because they are positives also, because these crystals are very small. They have very low power dissemination, and they are very low cost because they are basically sand. Sand is silicon dioxide, and crystals are quartz. So these requirements are met by 32768 Hz quartz crystals. So our quartz, all the watches have these crystals. They are powered by a microprocessor, and there is a small battery which powers this whole piezoelectric crystal. And a stepping motor receives 1 impulse per second, and which advances the second hand by 6 degrees, and that is 1/60th of a circle every second. And that is how we see this quartz crystal giving the time to us. I will talk about why this 32768 Hertz crystals were chosen, because if you divide divide this number by 15 times, divide by 15 times, so you will end up, you divide this number by 2, you will get 16,384 and so on, and then keep on dividing 15 times and you will end up at 1 Hertz. So by dividing this frequency 15 times by 2, you will end up at 1 Hertz or 1 second. So this is how your microprocessor in the quartz crystal processes this frequency information to the time information by frequency dividing and generating 1 second pulses. So the frequency of this crystal is fixed, and this is IES question which is very commonly asked. What is the quartz frequency? So the frequency depends on the thickness of the resonator. The thickness of the quartz crystal is very important. We know that the frequency changes with the temperature, and if we go to the hill or to a very hot place in a desert, we need to adjust our clocks. That is what we all know. We are aware. So that is why these clocks are temperature dependent, and they also have a slow variation with time. So they are not so accurate clocks. And that is why we thought that why not use the Earth's rotation, which is very perfect oscillator seems to us. So we think that is Earth a perfect periodic oscillator? So that is how the timing was defined in terms of the motion of the sun and Earth. So the second was defined as 1 by 86400 of moon solar day. So what is 86400? I think you all know 24 into 60 into 60 is 86400. And that is why second was defined on the basis of the rotation of the Earth. And between 1960 and 67, it was basically on the Earth's rotation around the sun. So 1 tropical year was considered, and that is why the 1 tropical year has so many seconds actually. So, but then it was found by the atomic clocks that the length of solar day is changing. So what does it mean? That Earth is slowing down actually. The Earth is not a perfect periodic oscillator. So Earth turns faster in the northern winter, and that is why when we measure the length of the day, we found it is varying every day. So this is what measured with the help of atomic clocks, and we found that Earth is slowing down. And why the Earth is slowing down? What is the reason for dynamic Earth? Because we have Earth which is having a dynamic phenomena like the tectonic plates and the movement of liquid core. And because you know that the mantle and core are liquid in nature, and Earth is having its own dynamics, and also there is a gravitational forces on the Earth. So, and there is an ocean loading, the melting of ice, the atmospheric pressure, the ocean currents, the winds, the gravitational attraction, the plate motion, the tectonic sea. So all this is leading us to variation of length of the day. And that has been measured and recorded, that how the length of day changes over a period of time. So that is why the 1967 became the era of atomic timekeeping. And if we study it a little more deeper, there was an earthquake in Japan, which is very famous, very major earthquake on the Earth, 8.9 magnitude earthquake in March 2011. This accelerated the Earth's spin, shortening the length of the day by 1.8 microsecond. So even an earthquake can change the dynamics of the Earth, and it can make the Earth become slower and faster or faster. So the events, it was recorded that melting of ice sheets or because of the rise in the sea levels also lead to the atomic the Earth's rotation, changes in the Earth's rotation. So all these reasons which I have written down here, whether it is plate tectonics or gravitational forces or viscous torques in the core or the atmospheric loading or the melting of ice, these are all the reasons for slowing down of the Earth. And that is what recorded in 1955 by this famous paper in Nature. And that is when we decided to move away from the Earth and define this time in terms of the transitional cesium atom. So that is the era of timekeeping. And we started with sundial, and we went to pendulum and Harrison calorimeter, and then these quartz crystals, and then now we have the atomic clocks. So what are these atomic clocks? The atomic clocks are basically the tiny atoms are the tiny oscillators, and we know that atoms have energy levels, and these are discrete energy levels. That means they are not continuous energy levels, but they are discrete. They are fixed, having a fixed difference between two energy levels. So these are called quantum states. These two energy levels where the atom electron can sit. Here I have shown E1 and E2 energy levels. So these two energy levels are quantum nature and they have a fixed energy difference. So the transition between two states can take place by absorption or emission of quantum of energy, which is called light. Whether it is called photon or radiation. So by absorbing or emitting, we can make a transition between two energy states. So basically electron is going from one orbit to another orbit. I think we are students of science, so we know very well that the atom consists of nucleus and electrons. In the case of cesium, there is only one electron in the outermost orbit, the valence orbital, and that orbital itself is having two energy states. So atomic clocks basically works by precise amount of energy is required for electron to jump from one energy state to another energy state, and by measuring the frequency of the electromagnetic radiation, which is creating this transition, we can measure the passage of time. So the atomic clock is an oscillator whose frequency is locked to the resonance frequency of an atomic transition. Now we will like to learn about how long is 1 second. We already learned that duration of 919263170 periods between these two states of the atom. These states are basically created by these inside a cesium atom. So the electron is either having a spin parallel to the nucleus or anti-parallel to the nucleus. If it is anti-parallel to the nucleus, then it is the lower state. And if it is parallel to the nucleus, it is a higher state, F is equal to 4 state, we call it. So these two energy states of the atom lead to the transition, which is basically helping us define 1 second. So in an atomic clock, we prepare the atom in one of these states, either this one or this one. So one of these states is chosen, and then we apply microwaves on this atom, and then we say whether the atom has changed the state or not. If the atom has changed the state, the frequency is correct. If atom has not changed the state, frequency is wrong. And we need to change the frequency till atom changes the state. So that is where we know which frequency is trying to create the change in the state of the atom. So in atomic clock, the atoms are moved. So you can see there are two kinds of atoms. One atom is having the different atoms are electron in this state. So initially we have mixture of atoms, and then we prepare the atom in one of these states, and then you see that is where the red top are going inside the microwave cavity where the radiation is coming on the atom. And here you can see that atom is not able to change its state. The microwave cavity is not able to change the state. But as soon as you fix the frequency to the correct frequency, the atoms change the state and they go to a different detector. So by changing the frequency of the microwave field, we are able to create a transition. So this was the first way, first atomic clock was discovered in 1949, and in 1953, this cartoon says that this is the most accurate time machine in the universe because no measurement was ever made more accurate than this measurement. And this is even more accurate than the movement of the Earth. So now what we have done in NPL is that we have tried to cool these atoms by the phenomena called laser cooling. So we shine the atoms, we shine laser lights on these atoms and try to make bunch of cold atoms. And these cold atoms are basically used in atomic clock. And the phenomena is like this: the cold atoms are created and they interact with the microwave field by going in a fountain geometry. So the atom is thrown like a ball up and it goes down like a cesium fountain, like a fountain of water. So it is very similar. This phenomena of atomic clock is one of the most precise atomic clocks in the world. Actually, no other measurement can be made in a more precise way than this atomic clock. And this has been made in NPL. and NPL has made a cloud of cold atoms, which is having 10 million cesium atoms inside a area of about 1.5 mm. So this is the atomic cloud of cesium in NPL, and you can see that these atoms are being trapped. These are cesium atoms, and we have made an atomic clock based on these atoms. And recently we have done some work on another atom which is called rubidium, and rubidium atom also is used to make an atomic clock. And here the transition is at 6.8 gigahertz. So this is an atomic clock which was put on the NAVIC satellite system. And recently we are trying to change the SI definition of second in terms of a single ion. And this ion is chosen to be yttrium 171 ion. And we will be proving a frequency of terahertz, 642 terahertz. This is different from the gigahertz frequency in a cesium transition. So this is much higher frequency in terms of the optical frequency standard. So what we have here is the atomic clocks, which are based on microwave or the cesium atomic clocks. These are called cesium thermal beam clocks. And I talked about the cesium fountain, which is having very good accuracy. This is a primary standard which has been developed in NPL. Now we are trying to make new clocks which are based on transitions in the microwave, the gigahertz, the optical region. And these are being tried with the in a single yttrium ion trap. So the application of these atomic clocks, we all know that when we measure when we use our GPS in our mobiles, they all work on atomic clocks, because these satellites which work on GPS, they are all atomic clocks. The GPS constellation which we are using every day is having 6 orbital planes. There are about 24 satellites, and all these satellites have 3 atomic clocks. They are mostly rubidium atomic clocks, and some of them are cesium also. And these are basically having 12-hour period. These satellites are having 12-hour rotation period around the Earth. And this GPS is owned by USA. And there is another Russian constellation called GLONASS, also having 24 satellites. And these satellites also get signals in India. So we have many constellations. These are called GNSS satellites. What we have developed in India after the Kargil war was the Indian own navigation system, which is called NAVIC. The old name is Indian Regional Navigation Satellite System, IRNSS. And these are 7 satellites. Each of them has them atomic clocks. And these atomic clocks are basically used for finding the position of yours in India. So if you have signals in your mobile from 3 satellites, you will be able to fix your location with the help of these 3 circles, the signals, because you are able to measure the path traveled from the satellite to the mobile phone. So that is why by triangulation method, the position of these 3 satellites is very well known. And that is why your mobile is able to calculate your position in real time by the help of 3 satellites, which your mobile signal receives from the. So if there is synchronization error between the satellite clocks of 10 nanoseconds, you will have a position error of about 3 meters, which you will not like to have. So that is why the synchronization between the atomic clocks is very important. And space clocks need to precise synchronize to few nanoseconds. And this is where we use the clock technology to help us in our everyday life. All the mobile phones not only use it for location, but also for satellite communication and also for the network. All the mobile networks, if there is a call drop, because your clock tower, the tower is not able to hand over the call while you are moving from one tower to another tower. And if they're not synchronized, the mobiles will not work, and there'll be call drops. So what is the time scale? How the international time scale works? What is the method by which we use this atomic clocks? So across the world, there are a lot of national metrology institutes like NPL in India. There's in USA it is called NIST. In Germany it is called PTB. So similarly, there are many NMIs across the world. Each country is having one national metrology institute like NPL in India, and all these contribute to the atomic clocks development. And then 450 clocks from these many institutes are making an international time scale called UTC. And this is also getting corrected from the leap seconds, with the help of Earth rotation measurements. Last leap second was added by NPL in December 2016 on 31st December. So if you remember, 1 second was added, and that is called a leap second because the Earth is having its own rotational speed and atomic clocks don't change. So that is why we need to match with the Earth, and that is why we need to add leap seconds. And in NPL, because we are located in India, we add exactly 5.5 hours to international time scale called UTC to generate Indian Standard Time. And this is what we are disseminating now to different cities, and we are making this 100 crore project in which we are setting up the atomic clocks at all these locations, whether it is in Bangalore, Faridabad, Ahmedabad, Guwahati, Bhubaneswar, and all that. And this will help the cyber security, the e-governance, the time stamping, the power grids, the defense, the finance, the banking, the telecom, the Airtel, the Vodafone, all these the grids and everything will get synchronized to the Indian Standard Time. So, and we need to synchronize to the world time. And because if there is a 16 second in India, the 16 second will be there in Tokyo also and Chicago also. So what it means is all the clocks in the world are synchronized to UTC to the one time, and they display the same second all over the world. So this was recognized by the Prime Minister and the President. In the 2021 speech of President in the Parliament session, in the budget session, he said new standards have been set in the form of national time scale by NPL India, and the Prime Minister subsequently inaugurated this new time scale of the country, which is called primary time scale, and this is the one which is generating the Indian Standard Time. And this Indian Standard Time is now coming to your laptops and computers with the help of the Internet Time Service of NPL, and the accuracy is about 100 milliseconds. And I think we all are aware that the network is used for dissemination of the timing technologies to the country. If you go to your laptop and computer and go to the date and time settings, go to the Internet Time and then go to change settings and then set NPL India, npl.time.npl.org as the IP address, you will be able to synchronize to the NPL time. So Indian Standard Time will be coming to your laptops and computers. So that is why I request you to use Indian Standard Time to set up your computer. Normally, when you buy a machine, you will be synchronized to the USA time because the time is set by the US, by the Google or Windows or some other US server. So I think it was mentioned by NISPR also that we are taking their help in time dissemination. The web server has been established, and we are also disseminating time through the web. You can go to the NPL website and see the current time of the day and how your laptop time or the computer time is different from the NPL time. So Indian Standard Time is basically key to the Indian science and industry, and it drives and underpins what we do and what we experience in our everyday lives, whether it is financial sector, the stock exchange. Recently, we heard about the case in which there was a co-location of the servers. So that is because of the timing only. Any issues with the financial services is because of the timing only. It is not correctly implemented. Navigation, the GPS, the Google Maps, all we use. The defense, whether it is the missiles which we have, or whether the spacecrafts which we have, they are all synchronized with the Indian Standard Time. All the power grids, the Panki power station, there was a problem of the synchronization of the grids, and that resulted in a blackout. So that can be avoided if all the grids are synchronized to the Indian Standard Time. All the moon mission, the Mars mission depends on the Indian Standard Time. The Airtel, the Vodafone, the MTNL all depend on the synchronization of their network on the Indian Standard Time. The cyber security we talk about, now there are so many cases, they all depend on Digital India and Indian Standard Time. The transportation, whether the movement of the aircraft or the buses and trains and vehicles, this all depends on the Indian Standard Time and how you synchronize the network. The digital signature, which we talk about, which is becoming so important in the modern days, and Internet of Things and the Industry 4 and artificial intelligence all depend on the Indian Standard Time. So all these missions of the government, they are heavily relying on the Indian Standard Time, and that is why we have a 100 crore project now of the Government of India. And we have a lot of R&D applications also, whether it is accurate navigation, the high-speed communication, or computation, the testing limits of fundamental laws of physics, they all depend on timing. and presently we can measure picoseconds, but can we measure attoseconds and femtoseconds? So I'll enter.
Dr. Agarwal, we cannot hear.
Oh, ma'am. Okay, ma'am.
There's no video. There's no sound, I mean.
Ma'am, I can share that. Okay, let me see if voice can also be shared.
Right.
Do you know how to share the voice? Let me try. We, anybody know who can help me with the transmitting the voice over the network?
One moment, so let me just see if I can. Just one moment. So there's a share computer.
Music or voice.
What's that?
So 1 minute, if
इधर एक option होता है table में आपने नीचे
so I think perhaps because there's no sound coming from
Okay.
there,
Okay.
we can
I
put
think,
the link. Yeah.
yeah, maybe I'll create a link after the presentation and then people can see. But I'll
Sure.
anyway have the subtitles. You can see what Prime Minister is speaking at least.
For
You know,
sure.
already subtitles are there in the video, so probably people can guess what Prime Minister is speaking. Okay, let
Right.
me run it. Yeah, that's all from my side. Thank you very much all, and I hope you like the video. That's all from my side.
Thank you very much, sir. I think because of the sound, since our Honorable Prime Minister Shri Modi ji is such a charismatic speaker, it would have been nice to have him here because he's very passionate about anything and everything where India's success is concerned. So I think in terms of next, what we will do is we are opened up the chat. So if the teachers have a question, I'll save my question for later, but the teachers have a question, perhaps they can please share it on the chat box and Dr. Agarwal can then answer the questions. So the chat box is now open for everybody to type their question. Does anybody have a question? So while everybody is thinking of it, I wanted to ask you a question, Dr. Agarwal, from the onset of this webinar. So apart from stability, is there any other reason why cesium is the element that is primarily used for the determination of, I mean, in terms of the calculation of time, or is there any other reason for that? I know you've mentioned rubidium is another one that is currently also in the works, but I'm assuming cesium is used more frequently.
Agreed on that, ma'am. Very correct question, ma'am. This whole work was started during World War II. And that time, when we are trying to interrogate an atom, when we are trying to create a change of state in the atom, we need to choose a very narrow line with frequency. So because atom need to only see one frequency, which can change the state of the atom. So now the atom which is having the highest energy difference in the ground state was found to be cesium. And that is because, you know, the rubidium is having a lesser energy difference, which is 6.8 gigahertz compared to the cesium is 9.1 gigahertz, little higher energy difference. So that is the reason when the cesium atom was chosen as a standard for frequency, and microwave radiation was discovered at that moment of time to easily interrogate the atom, and that is when you know, because the atom need to be such that it is only having one electron in the outermost orbit, and that is the first periodic table elements, starting from hydrogen. So there is another atomic clock which we called as a active hydrogen maser, is also a atomic clock based on the transition in hydrogen. It does not even use cesium or rubidium. It uses just a molecule or a atom or molecule of hydrogen. Yeah, I hope it answers your question.
Yes, yes, it does. Just out of, you know, common curiosity. Science is a very fascinating subject, and there are elements of physics, chemistry, biology in each and every realm when we take a look at it operationally, of course, in everyday life. So there are certain elements. So you've addressed the physics and the chemistry. I think the biology part is, or maybe I missed it, but the bio part is missing apart from our eyes actually reading.
Yeah, ma'am, basically, whenever we perform nowadays, we are talking about robotic surgeries. And when we are talking about healthcare over the internet and the remote intervention by the doctors or the microsurgeries by robots, they all depend on timing heavily. And when we are trying to do any modern technologies, whether in healthcare or telemedication or anything related to the instrumentation in the operation theater, this is all governed by the accurate timing, actually.
Yes.
Yeah.
No, time needs to be given, or in every sense of the word, it's very important unit, not just of measurement, but also of our everyday life.
Yeah, absolutely.
Do any of the teachers have a question that they can potentially type in the chat box? The chat has now been turned on. So anyone has a question?
Did I go too fast or something? I mean, because time was a little limited. So
Yes.
probably it was a little heavy dose of physics and all that.
So is these concepts, so just to ask you on a completely different note, these concepts, recent concepts of wormhole and things like that, of course, they have a lot to do with time. In your opinion, are these something that actually exist in time? I mean, there are many such theories of parallel time, parallel universes, and so on and so forth. And they're all the basic ground is time for all of these. So, in your opinion, is that something that exists? And
yeah, ma'am. Very, very good question again. See, the concept of cosmology and the Big Bang and the expanding universe and how these black holes and astronomical measurements are being measured and done. When we have even in our UT also we have radio telescopes which are many in number, and they all are measuring same signals from different parts of the world or parts of the galaxies and different parts of the universe. So all the signals they need to be synchronized to each other, and that is why all the radio telescopes they are using atomic clocks to do those measurements. Otherwise, those measurements will not have any meaning. And even the black hole discovery was based on the accurate measurement because of the timing synchronization of those devices. And even the CERN experiments which are going on, particle physics or the God particle and all those new fascinating areas, they all depend on timing and time synchronization, because all the devices, they need to be synchronized in time, then only science will work. So the AI and the IoT is fully dependent on timing technologies now.
Right.
Yeah.
Fascinating.
Yeah.
Fascinating.
Yeah.
I think I can have a ton of questions around these lines. It's a very fascinating topic for me personally. So if the teachers don't have any other questions, or if they think of a question afterwards, please do forward it to us if the students have a question, and we'll try to get that answered from Dr. Agarwal. So just one more round. I think there are no more questions that are coming up.
The colleagues from NISPR also, and anybody who is on the attendees can also himself if at all anything is there.
Indeed, it's open. If anybody has a question, please feel free to ask. No. So for the benefit of all the teachers who are on this call, our next webinar will be on Friday, September 19th at 4:30 p.m. The reason why we have pushed the time is to make sure that the students and the teachers, since the schools are now in an offline capacity, that they have enough time to come home and can attend the webinar. So details we shall share with you later, but that's some information on our next webinar. So that's about it. I'd like to, Dr. Agarwal, I cannot thank you enough. It's a very fascinating topic. And as I said, thank you so much for sharing that bit. It gives a large amount of perspective. And you helped put all the chemistry and the physics, in terms of the elements and how they can be used in our everyday life. So it's very nice to see the real life applications of it. So thank you so much for taking the time and for explaining it to us. The video recording of this will be shared with all the schools and the students, and it's free it's open, so the schools can share it with the students of standards 11, 12, and so on and so forth. So thank you once again. Dr. Suman, thank you so much for helping us organize this. Everyone else, the teachers who are on the call, have a wonderful evening, and we will see you next time. Thanks everybody for joining us, and have a great evening. Thank you, Dr. Agarwal, once again. Thank you.
Bye-bye, everyone.
Bye-bye.